400 feet of stone. 30 miles of light. 15 centuries without failing. The Lighthouse of Alexandria achieved the impossible. And nobody knows exactly how. The year is 283 BCE. King Ptolemy II stands on Pharos Island, watching workers haul the final stones into place. Behind him rises the most ambitious structure humanity has ever attempted. Not a tomb. Not a temple. A lighthouse. But here's the mystery that has haunted engineers for 2,000 years. How did they build it? The techniques required shouldn't have existed. The materials needed weren't supposed to be available. The precision demanded was centuries ahead of its time. Yet there it stood. 400 feet of gleaming white limestone topped with a bronze mirror that ancient sailors claimed could project fire visible from over 30 miles away. And this leads to the central question nobody can answer. What knowledge did these builders possess that we've somehow lost? If this is already challenging what you thought you knew about ancient capabilities, that like button helps more people discover these mysteries. Now let's talk about the foundation. Because this is where the first impossible achievement happened. The lighthouse was built on Pharos Island, a tiny strip of rock constantly battered by Mediterranean storms. Any modern engineer will tell you building a 400-foot tower on an island requires bedrock anchoring, concrete pilings, and steel reinforcement. The ancient Egyptians had none of these. What they had was something else entirely. They used a technique called interlocking stone foundations. Massive blocks weighing up to 75 tons each, carved to fit together like three-dimensional puzzle pieces. But here's what nobody expected. When French archaeologists examined underwater fragments in 1994, they discovered the stones were joined using a mysterious morite-based cement that actually hardened underwater. But here's where it gets strange. This underwater cement wasn't supposed to exist. The first modern hydraulic cement, the kind that hardens in water, wasn't officially invented until 1793 by John Smeaton. That's over 2,000 years after the lighthouse. So where did this technology come from? And why was it forgotten? Imagine you're a Roman engineer in the 1st century CE, standing before this lighthouse. You've been tasked with replicating it for Emperor Claudius. You have access to Roman concrete, the finest materials in the known world. And yet, every attempt fails. Roman lighthouses rarely exceeded 100 feet. They crumbled within decades. The Alexandria lighthouse stood for 15 centuries through earthquakes that toppled entire cities. Something fundamental was different about how the Greeks and Egyptians built. And the Romans, for all their engineering genius, couldn't figure out what it was. But that was just the foundation. Now let's talk about the structure itself. The lighthouse consisted of 3 distinct sections. The base was a massive square platform, roughly 100 feet tall. Above that, an octagonal middle section rose another 115 feet. And crowning it all, a cylindrical tower topped with the flame chamber. Think about what this means. Ancient workers had to lift 2-ton blocks 400 feet into the air. They had no electric cranes. No steel cables. No hydraulic lifts. According to ancient accounts, they used an internal ramp system that spiraled through the structure itself. Workers and pack animals would carry materials up this continuous incline. But here's the engineering puzzle. A ramp covering 400 feet of vertical rise would need to be over a mile long. How did they fit that inside the structure without compromising its integrity? Keep watching, because underwater archaeologists found something that might answer this. If you want to see how this engineering mystery gets solved, make sure you're subscribed. Because everything you've heard so far, that's just the setup. Now here's what changes. Everything. In 1994, French marine archaeologist Jean-Yves Empereur made a discovery that rewrote our understanding of the lighthouse. Diving in Alexandria's eastern harbor, his team found massive stone fragments on the seabed. Not just any stones. Granite sphinxes. Colossal statues of Ptolemaic kings. And most importantly, precisely carved channels running through the lighthouse blocks themselves. These channels weren't decorative. They formed a hydraulic network. Some researchers now believe the lighthouse contained a water-powered elevator system. Pressurized water flowing through these channels could have lifted platforms carrying heavy loads. If true, this means the ancient Egyptians created hydraulic lifting technology 1800 years before it supposedly existed in Europe. Drop your theory in the comments. How do you think they really lifted those blocks? Now let's talk about the flame itself. Because this is where the lighthouse earns its legendary status. Ancient sources describe a fire that never went out. For 1500 years, through storms, invasions, and political upheaval, the flame burned. How? The answer lies in a sophisticated fuel delivery system. Historians believe attendants maintained a constant supply of oil or possibly resinous wood, hauled up through the internal passages day and night. But the fire alone wouldn't have been visible from 30 miles. The secret was the mirror. Ancient accounts describe a massive curved bronze mirror, possibly 20 feet across, positioned behind the flame. This mirror didn't just reflect light. It focused it. Ancient Greek mathematicians understood parabolic curves. They knew how to shape metal to concentrate light into a beam. And this is where I need you to pay attention. Because the mirror technology reveals something profound about ancient knowledge. We often assume technological progress is linear. That ancient peoples knew less than we do. But the Alexandria mirror demonstrates mathematical understanding that wouldn't be formally documented for another 1500 years. The calculations required to create a parabolic reflector that could project light 30 miles requires precise understanding of focal points, angles of incidence, and reflection geometry. The Greek mathematician Archimedes, who lived around the same time as the lighthouse's construction, wrote extensively about curved mirrors. Some scholars believe he may have consulted on the lighthouse's optical system. And then it got worse. Because when the lighthouse finally fell, this knowledge didn't just become forgotten. It became mythologized. Medieval accounts claimed the mirror could set enemy ships on fire from miles away. So what actually destroyed this wonder of the ancient world? Not time. Not war. Earthquakes. The lighthouse survived its first major earthquake in 956 CE. Then another struck in 1103. And again in 1303. Each time, the structure weakened but refused to fall. The Mamluk Sultan Qaitbay finally used the ruins to build a fortress in 1480, incorporating surviving lighthouse stones into its walls. You can still see them today. But here's what's remarkable. That fortress still stands. Built with salvaged lighthouse materials using construction techniques the Mamluks learned from examining the ancient structure. In a very real sense, the lighthouse never truly died. Its engineering DNA lives on in a building you can still visit. The knowledge wasn't completely lost. It was inherited, transformed, passed down through stone and mortar to future generations. I want you to remember this part. Because everything we've explored leads to a single profound realization. The lighthouse wasn't just a building. It was a statement about human possibility. Constructed by people with no electricity, no computers, no modern metallurgy, it achieved feats we struggle to fully explain today. The underwater cement that hardened in the sea. The hydraulic channels that may have powered lifting systems. The parabolic mirror that turned fire into a 30-mile beacon. These weren't accidents. They represented accumulated wisdom passed down through generations of builders, mathematicians, and engineers. The knowledge existed. And then, over centuries, it fragmented. Pieces survived in Arabic texts. Others in Byzantine manuscripts. Some remained encoded in the stones themselves. What we call lost knowledge wasn't destroyed. It was scattered. And modern archaeology is slowly piecing it back together. We're almost at the moment everything comes together. Because here's the final piece of this puzzle. In 2012, Egyptian and French researchers created a complete digital reconstruction of the lighthouse using sonar mapping of underwater debris and analysis of ancient texts. For the first time in 500 years, we can see exactly what the lighthouse looked like. And the reconstruction revealed something unexpected. The structure was even more sophisticated than previously believed. Multiple fire chambers at different heights. A complex system of bronze doors controlling airflow to the flames. Ventilation shafts that prevented smoke from obscuring the mirror. This wasn't primitive engineering. It was systematic, calculated, brilliant. The lighthouse builders solved problems we didn't even know existed until we saw the evidence. And this is the big reveal. The Lighthouse of Alexandria wasn't an anomaly. It was the pinnacle of a tradition. A tradition of engineering knowledge that developed over centuries in Egypt, Greece, and the wider Mediterranean world. We see traces of this knowledge in the pyramids, in the Parthenon, in harbors and temples and palaces across the ancient world. What made the lighthouse special wasn't that it represented knowledge appearing from nowhere. It represented knowledge reaching its peak. And when that peak crumbled, the path that led to it was still there, waiting to be rediscovered. The next time you see a modern lighthouse, a skyscraper with an observation deck, or a building designed to withstand earthquakes, remember. You're seeing descendants of ideas first mastered on a tiny island in Alexandria.